Okay, today's topic is going to be more on organizing word problems. Continuation of a theme we had a couple of months back. So we do have the usual copyright notice. Here's that. These are all problems from the GMAT prep software, and all of them are copyright GMAC. Of note is the fact these are all from the free GMAT prep software. That's important. We can't use problems from the paid question packs. So when you submit those, either here or to the forum, please take note. They've got to be questions from the free software. Thank you. Okay. Let's do one. Give this a shot. And again, don't forget where you find answers to multiple choice questions. Those are found here. Give it a try. This data sufficiency, by the way, we do assume that you are familiar with the data sufficiency question format. If anybody doesn't know that format, I can put the answer choices on the board with sufficient and not sufficient. Although you'll have to try to follow what we're doing with sufficiency. But give it a try. Okay, it's a long problem, so if you're taking a little bit longer, that makes sense. But if you are not honestly progressing towards a solution that you are definitely going to get, you should quit. Give me about another 30 or 45 seconds. Okay, we still have a lot of people with blank responses here. If you don't have something, please try to have something at this point. Okay, interesting. I'm noticing, I don't normally show response distributions on the board, but this one is interesting in the sense that there are three answer choices that are almost equally popular, A, C, E. So it looks like you guys as a group mostly realize that statement 2 is not sufficient because B and D were not very popular. But let's talk about how to do this. Obviously a challenging problem. So there's no more than a quarter of you guys picked any given answer choice. So let's take a look. As a quick reminder of the discussion that we had about word problems last time we did this theme, which was November 13th of last year. Rather than going through that whole thing again from point number 1, I'll just give you a very quick summary from 11-13 study hall. We talked about organizing word problems. And the deal is the reason why people find word problems hard is because they either don't organize them or organize them only while they're trying to do the work. So, and to make word problems a lot easier for yourself, you can separate those tasks. It's 3 different tasks. The first is organizing the situation, or making a framework. The second is inserting information into that framework. And the third is actually solving the problem, coming up with strategies, etc. So notice you don't even do the problem solving part until you have done these things. That's supposed to say bye up there. Okay. And I mean, this is what people do in the real world, and this is why real world word problems are not nearly as taxing as these. Speaking of taxing, like a lot of people make spreadsheets for their taxes, and when they first make the spreadsheet is empty. Not an amazingly remote realization, but people don't bring those skills here. So how do we make a framework for this? problem. It doesn't have to be elaborate. Like, what should we have as a framework here? What should it look like on our paper? You should have country names A through F. Yeah, okay, because it's 6 countries. So A through F is a pretty good way to do that. And you can just make columns here. In some kinds of problems, a chart is more appropriate, like if you have rate, time, distance for different legs of a journey or something. But here you just have a quantity for each, right? So 6 columns and A through F. So let's just go ahead and do that on the next page. Same problem, a little bit smaller. So again, we're going to organize, then we're going to insert information, and only then are we going to solve. So here, A, B, C, D, E, F. Okay, and then technically we need 2 frameworks because there are 2 statements, but we can just put horizontal lines to divide this up. So that is not really a problem. Okay, there's a framework. That's not super complicated or anything. Tutor says x equals 75. That's part of inserting information into this. So that's more like that's not really a column of the spreadsheet. That's more of something you're going to insert into it later. So statement 1. Statement 2, and then if we have to combine them, we can combine them if necessary. Okay, insert information. The goal here is to go through this paragraph exactly 1 time and then be done with the paragraph forever. Because that's where efficiency comes from, is not having to go through the same information repeated times. So I think there's a little bit of a sound delay right now. See if I can move closer to my wireless router. Okay, I think you guys should hear me okay again at this point. All right, so the goal is to go through the paragraph exactly 1 time and then to not really ever have to deal with it again. So there's a total of 75 representatives, so let's just put that in there with plus signs. Okay. And then all different, so I'm going to note that on the side here, because otherwise I might be tempted to put the same number in there. By the way, as dumb as this sounds, one of the biggest reasons why people get these wrong, even people scoring at very high levels, is because they just forget about conditions that are imposed on the number. And there's a very easy way to keep yourself from forgetting such conditions, and that is to write down all the things. Write down all the stuff all the time. Don't make yourself remember things is the name of the game. Because if you have to, even if you successfully do remember that, it just takes up real estate in your brain that you could be using to solve the problem. Okay. So then, if country A, so country A is the second most. So let's just write that there. All right. And then the question is, did country A send at least 10? Okay, now, here's the other problem. Here's the other reason why people find this hard. Because they don't know what they're actually trying to do. Sounds weird. But can anyone tell me in the chat box, what are you actually trying to get these numbers to do? Not really a minimization problem, although you might be Okay, like that, where Ash is going with that is a little bit more accurate, although you don't need 9 and 11. I mean, at least 10. Yeah, you can try for 9 and 10, because it might be possible that you could get 10 and not 11, in which case that would fall flat. So, but yeah. So the deal is, for every yes/no question, you should be trying to do what these people are doing in the side chat box there, which is first immediately translate the words yes and no into specifics. And then you are done with yes and no forever. You should never think about the words yes and no ever again after that point. Because that's what makes this hard, is that people are thinking about the words yes and no. The problem is those are not things that exist in the problem. I mean, you can't manipulate a bunch of numbers and have the word yes pop out. It's not a thing, right? So you need to know what specifically we're actually trying to do with the numbers. And then, because yes and no, so then for each statement, write those two specifics with question marks. And then just make sure you know that the goal, if you can circle them both, then that's not sufficient. And if you can't circle both, that's sufficient. And you can't make them both happen. So just do this, and even if you find that the problem is not that hard, you should still do this, because habits, in order to build something as a habit, you're going to have to do it all the time. So let's just write those two goals there. A yes here means that A is 10 or more. A no means that A is 9 or less. So let's just write those here. Can I make A greater than or equal to 10? Can I make it less than or equal to 9? Same thing here. And this is a very simple thing to do, but now you know what you're trying to do. And you can look at these with your eyes, and they're your goal. So you're actually trying to get happen here. And notice that you're trying for not sufficient. Like the thing that is your goal is to try to make both of those things happen, because you can't try to make them not happen. So this is what you are ultimately trying to do. Okay, statement 1, you can make country B the one with 41, because we don't know which one that was. So let's just make the country with the most people B. Okay, it's got to be 41. The point is that we want to try 10, and we want to try 9. Numbers like 11 and 8 are not as good because they're not the border cases, right? You want to try the numbers that are right on the border between these possibilities. So we try to put a 10 here. This is 51 representatives, so you have 24 left. Just try to keep a running total of that in your head. So if that's 9, I got 15 left. If that's 8, I've got 7 left. And then I can make these like 4 and 3. Once I make this happen, okay, I circle this because I made this happen. What is my only goal in life at this point? Yeah, let's try 9. And again, you don't want to do like unnecessary work here. I mean, B still has to be 41. If we try to make this 9, I mean, I don't need to think about 75 and do a bunch of arithmetic again. I just need to look at what I'm doing to these. Notice the 9 and the 8 have to go down. But yeah, okay, now there's 3 or 4 things changing, let's just do the arithmetic. Okay, this is 50. What's the biggest number I can put in C? 8. So that's 58. That's 65. That's 71. And that's 75. So it's close, but this works. What have we just proved? Almost by accident. In fact, we've proved not only that the statement is not sufficient, not just this statement. In fact, what else have we proved? Because if you look at these, yeah, right, these are both less than 12. So the point is that you can absolutely recycle both of these cases. You could, copy and paste them, so to speak. Because the same thing works for statement 2. You can use exactly the same numbers. So that's an accident. It's not always going to happen, but here it does. And then, of course, you can, even if you think about combining the statements, I mean, since those cases work for each one of them, you can use them again. So together, they are absolutely still insufficient. So, which is going to be E like elephant. So, and notice that this problem, I mean, you can expect problems like this to take a decent chunk of time. But if you really do this in a way that is organized, it takes a lot less time than you would probably think it would. Because you don't really have to do anything past statement 1 if you pick these cases in a way that makes sense. So E and elephant. And again, if you took a long time to do this, you need to think about why. You need to think about where that time went and about what you could do to not spend so much time. Basically things like organizing, but also writing out these goals. Because if you're looking at these with your eyes, it's just not as hard. You're not going to spend as much time because you don't have to keep recalling what the task was. All right. Any questions about this? I think one person is typing. Let's see. Tiffany, of text in your box. Are you asking a question? If not, then okay, no questions. Cool. All right, let's move on to another one. Try this. This one shouldn't. Prashant, please look on the screen for where your answer goes. Thanks. Guys, I'm thinking these directions to be clear, but please do not answer the question in the chat box as it says on the screen. Thank you. Okay, if you don't have an answer to this, please pick one, and please pick it in the right place, guys. I think I'm going to start actually disabling the chat box while the question is on the screen. Okay, so at this point, Bill, I don't know if this is a practical joke on me, but do not answer the question in the chat box. Okay, let's take a look. So the thing with this kind of problem is we have equal numbers of people, approximately equal numbers of people picking choices B and C, and to a lesser extent D. The point is that when you read the problems, when you organize the problem, when you make a framework, or just when you go through the information for the first time, pay very careful attention to the words they use for quantities. Because if they use the same name for something, then it's going to be the same quantity. That's the point. So if you look at this problem, the deal is, because you see the total fines here. And so then this might make you think that we're going to deal with fines on a daily basis and maybe also a total fine. But let's just look what they do in the rest of the problem. So this still just says the total fine. And then this still just says the total fine. So we actually don't have to deal with any other fines. We don't ever have to think about anything but this. So just the total fine, it doesn't matter what it's called. It's just, you can call it X. There's nothing else. There's no other quantities in the problem. I mean, in particular, there's never any point at which you add things up and get a fine. So if the point is that it's either increased by 30 or doubled, whichever is less. So if that amount X is 30 cents or less, then you add 30 cents. And if it is 30 cents or more, you double it. And we notice that if it is 30 cents, you can do either of these because they're the same. So this is the point. And if you got this problem incorrect, it's probably because you were making it more complex than it has to be. So as far as the framework for the problem, all you really need is number of days and then X. That's good enough. Okay. On the first day, they say that it is 0.010. It is 10 cents. On day number 2, well, that's less than 30 cents. So we do what? We double it. Actually, I have these inequality signs are backwards. It's whichever one is less. Sorry about that. So that should actually be, that's what you do if it's more, and that's what you do if it's less. Yeah. So we double it, that gives us 40 cents, 20 cents. Day 3, we double it again, 40 cents. Day 4, what do we do? You add 30 and you're done, and that's it. And it's 70 cents. Yes, that's all you got to do. But the point again, just be aware of what they are calling things, because I mean a lot more people got this wrong than right, so apparently it's not that easy. But because again, the thing is that they did put the word total on there, which kind of makes you think you would have to add things at some point to get it, but you don't, because they only have one quantity that they've named in the problem. Because one thing, the people who write these problems are definitely not careless with words. So the total fine on day 2 is not 0.3. Again, that's actually my whole point. I mean, this is, if the word total fine confuses you, then just call it X. Because they just keep calling it the same thing every time. On the first day, X is 10 cents. If it is, then for each day, you either double X or you add 30 cents, whichever one would be less. So here, doubling it is going to be less. And then here, doubling it is still less. So the double of day 2 would be 40 cents, as we have here. So no, it wouldn't. I mean, if you have to write these out so that you can look at them, you can also do that. Just write more things down. If there's any confusion at all about anything, then write more stuff down is pretty much the answer to absolutely everything in the world here. So if I double this, just write it down. If I double it, it's 20 cents. If I add 30, then it's 0.40. So I don't want the bigger one. So this is gone. If I double this, it's going to be 40. If I add 30, it's going to be 50. Again, I don't want that. If I double this, it's going to be 80. But if I add 30, it's going to be only 70. So this time I want the 70. And that's it. So, I mean, if it is hard to interpret, it isn't really. But if you find it that way, it means that you're not spending enough time going through the words. I mean, don't rush this. I mean, if you go through this slowly and carefully, then you will notice that there is only one quantity ever mentioned, which is, quote, the total line, unquote. At which point you could just give it a name like X. So, but it shouldn't really be hard to interpret if you are not rushing through it. So I would guess that might mean you are rushing through it. So don't do it. I mean, the Marines, they have a saying, slow is smooth and smooth is fast, and they are right about that. It takes a lot less time to go through something once slowly than it does to go through it 5 times fast. Because if you go through things fast, you're going to have to keep going through them over and over and over again. Okay. Time to write another one. There's one person with typing. Yeah, I mean, again, I can testify firsthand to this too, because I am a very, very slow reader, so, and I don't really have too many issues with that. Okay, try this. I'm gonna, because you people are today's crowd is not so great at following directions, so I'm actually gonna disable the chat box while the question is on the screen. Yeah, it's like first grade, right? I'm going to take away your chat box. Okay, this is where you should put your answer. You should put it there. Go for it. Okay, guys, if you don't have something by this point, you should put something. I mean, we have, if you need to guess, you should not feel bad about guessing, because look at this profile of answers, right? I mean, people are not so much picking A, but we got almost equal numbers of people picking everything. So if you have to guess, you should just guess. Okay, let's talk about this. So again, you want to organize it first, then you want to think about the information, and then you want to solve the problem. And it's a yes-no problem, so you want to do what you normally do with yes-no. But first, let's just take a look. So you have a company with 2 divisions, and then the way they wrote this, you can tell that the 2 divisions basically add up to be the entire company. So if you want to framework that, you can start by making those rows. So division X, division Y, and then you can have the whole company. Certain things are going to add, certain things are not, but we'll get there when we get there. And then we have part-time employees and we have full-time employees. And I mean, common sense says that you can't be both of those things. So that's how they divide up the employees. So part-time, full-time, total. Okay. And then the deal is the ratio of we're interested in the ratio of part-time to full-time actually going around. So maybe we can get rid of total here and put full-time to part-time. And you're going to want to do this twice because there are two statements. So let's do it again over here. All right. So then you want to look at these. And then what you're trying to do is you're trying to see if the top right box is greater. So again, the yes/no question thing, get rid of the yeses and the nos. So this is more than the bottom right would be a yes answer. And this is less than or equal to the bottom right would be the no answer. Same sort of thing. And if we can get both of these to happen, then it's not sufficient. Yeah. All right. Now what? Does anybody have any thoughts about this? This is kind of an interesting thing that they're asking us about. Does anybody know how we could think differently about this? Or maybe less vague. So not how to solve it. Yeah, that's a way you could approach it. But what quantity could we consider instead of considering this quantity? Yeah, you could just think about percentages, right? So especially when it comes to data sufficiency. So let me show you on a separate screen here. I mean, there are a lot of quantities that are very closely related to each other. So the first is the ratio of two things. And I'm just going to talk about men and women just because that's one of the most common things you'll see in the problems, but also because it's very intuitive to think about that. So the ratio of men to women is very closely related to the percentage of men in total, which would be very closely related to the number of men as a percentage of the number of women, which would be very closely related to the number of men is how many percent greater than the number of women or less. All of these, if one of these things increases, then all of them will increase. And if one of them goes down, then they will all go down. So, like for instance, if you have a ratio of 3 to 2 men to women, then that means that there are 3/5 of everyone is men, because you could separate them into groups of 3 and 2. So the percentage of men out of everyone would be 3/5 is 60%. The number of men as a percentage of the number of women is 150%. And then the answer to the last question would be plus 50%. And like, the point is, if any of these things changes, then all of them will change. They will all change in exactly the same direction. So if you have like a ratio of men to women, that is, let's say that goes up to 3.5 to 2, which is the same as 7 to 4. Then the percentage of men, it's not supposed to be, okay, yeah, the percentage of men out of everyone is now at 7/11, which is going to be 63.63.6363. The number of men as a percentage of the number of women That's going to be 7 to 4, so 175%. This is going to be 75% increase. The point is that all of these increase, and all of them will increase together, or they will all decrease together. So if we want, we can think instead about the percentage of full-time employees. So let's see how that goes. So in other words, as a proxy for this, we can just talk about percent full-time. Same sort of thing here. I mean, we'll try taking a look at this later on with the literal content there. But this is going to be a lot more instructive to look at. So statement 1, again, as we mentioned on the other page, if this ratio is less, then the percentage will also be less of full-time people. So if this is true, then the percentage of full-time employees is lower for division Y. But wait a minute. So like if this is some quantity Q, and this is going to be less than some quantity Q. So look what they're asking here. I mean, again, you can use that percentage as a proxy for this ratio. The question is basically, is the percentage of full-time employees greater for division X than for the whole company? So, well, I mean, if you think about it, it has to be. Because if you think about how percentages work, like if this was 40% and this was like 37%, then this can't also be lower than 40, because your weighted average would have to be somewhere between these two things. So if this is Q and that's less than Q, then as a consequence, this must be greater than Q. So this statement is sufficient. We actually don't even have to do any craziness with math here. But number 2, more than half the full-time employees are employees of division X, and more than half of the part-time employees are employees of division Y. So this means that division X has more full-time people than division Y does. So that is bigger, and this is smaller. Saad, if you have a question, just type it in the chat box, please. If you the rest of the statement says that more than half of the part-time employees of company Z are employees of division Y, which means the division Y has more of the part-time people. So this is bigger and this is smaller. If you wanted to call things quantities, then you could say this is like X is less than X, and this is Y and less than Y. Now it's more convenient just to look at ratios again, because this, if you take the ratio of full-time to part-time, that's a bigger number over a smaller number. So color code that accordingly. So no, those are actually percentages. So if you want to think about literal percentages to help your intuition out, that might help you. Like if this is, the example I gave, if this was like 40% and this was 37%, this is be something more than 40%. So they don't add because they're ratios or percentages. You can't add ratios and you can't add percentages. So there you go. This is going to be a smaller number divided by a bigger number. So the deal is, again, if you think of these as percentages, because as we mentioned here, all these things scale together. Like you can actually just switch back and forth, like switching between two languages, right? If you are talking to a friend and both of you speak both English and Tagalog, you can switch languages whenever you want. It's like that. I mean, you can just switch from thinking about these to thinking about percentages again. The deal is that the company is only made up of these two divisions. So this division has a bigger percentage of full-time people. And this has a smaller percentage of full-time people. So if you think about how these are going to play out in a weighted average, this is going to have to be greater than the weighted average. This is going to have to be less. Because the weighted average consists of only those two things with their according weight. So this, again, this is the box that is the weighted average. So this is once again sufficient because this is more than that. So this is sufficient. This is also sufficient. This is going to be D like dog. Are there any questions about this? Now, what we just did there, that requires this insight. That requires the fact that you can scale these. So let's see what happens if we just use the more literal content of the question. But just make sure that you know this is a huge takeaway because there are lots and lots and lots of questions about these things. So an article. Tutor, I don't really have articles in general, so I'm not sure what you mean by that, but yeah. Okay. Let's take a look at this. Let's see what happens if we do this with the literal content without rephrasing it into percentages. Let's see how that works. So two charts again. I mean, as far as tutorial, man, I guess you're looking at it. I guess this can be considered a tutorial. There are lots and lots of other archived sessions about word problems and stuff. In fact, I think there's also an entire session about weighted averages. So if you dig through the archive, man, there's so much stuff in there. We've been doing this for a very, very long time. Okay, so again, I'm just going to make these colored boxes. So goal is to find out which is bigger between the blue and the green, right? So the things, the two yes/no possibilities are, is the blue thing greater than the green thing? And is it not? Okay. Let's see what happens if we do this with the literal content of the problem statement. And let's make those blue and green boxes come over here too. Okay, let's see what happens. So statement 1 says, and notice that you can, what can you add? Like which columns will actually be top plus middle equals bottom? Nobody? Which columns will allow you to add the first two things and give the whole? First column will, because that is a number of people, and you can add numbers of people. And the other column. And the second, right? Because those are both numbers of people. But in particular, you can't add ratios. So that's not going to fly there. Again, do it here, write it down on the chart. This is just part of organizing. That way you don't have to keep this in mind. All right, statement 1, the ratio of the number of full-time employees to the number of part-time employees is less for division Y than for company Z. So, in other words, literal ratios. So let's say that this is, let's call this L for less. And let's call this R for the entire thing. So then let's say that there are, how do we want to do this? Let's say that there are P number of part-time employees here. Then this is PL number of those. And then let's say that there are W part-time employees in whole, in total quantity. So then that means RW. So then this would be W minus P, and this would be RW minus LP. And this would be RW minus LP over W minus P. Okay, well, so we want to know how this compares to R. So let's keep that there just to remind us. So at this point, let's just express the question. So this is the question. Is RW minus LP over W minus P, is that greater than R? We can multiply both sides by W minus P because it's a positive number of people. So if we do that, then we get this. Okay. Now remember that L by definition is less than R. So this is the same thing minus something that is smaller, and this is the same thing minus something that is bigger. So if you subtract something that's bigger, you are smaller. So this is definite, and this cannot be done. So this is sufficient. Any questions about that? I mean, that's just kind of doing without. I mean, as you can see, it's much more of a pain in the butt. But, yeah, it is what it is. Okay. Statement 2, we could probably just try to do the same sort of thing. More than half full-time employees coming here are employees in Division X. That means that this is more than that. Yeah, I mean this is more than this. So if I say that is, I don't know, Y plus some increment and Y, and then half the Division Y has more part-timers, so we can call it X plus a quantity. So therefore, these are all positive, is the point. If we add these, then that's 2x plus b. And this is 2y plus a. And the ratio is y plus a over x. And this is 2y plus a over 2x plus b. So then let's see what happens if we do this again. Blue later than green question mark. Well, so you can multiply by x and by 2x plus b. So I'll just go ahead and do that to save some typing time here. So that would be y plus a times 2x plus b. Is that greater than 2y plus a times x? question mark. So if we, I think I'm missing a parenthesis somehow. Okay. If we do this out, 2xy plus 2xa plus by plus ba. This would take much less time handwritten, of course. 2xy plus xa. And then we can knock out the 2xy and one of the xa's. So that's true because we defined these so that these are all positive quantities. So this has to be true, and it works, and we're done. So there it is. Again, notice without organization, you are definitely not going to make something like this happen. But with organization, I don't need to keep in mind any of this because it is all there. And so then I can focus on writing out something like this and doing it. And, you know, this is not totally insane. I mean, if they have this kind of thing, then you can bet that there are going to be more efficient solutions. But the point is it shouldn't really matter. You just do what you can. You just do whatever comes to mind. Difficulty levels, no one cares because you won't know. In fact, if you think about the fact that you are asking that question, that's proof that it is useless to even know the answer to it, because you won't have any idea ever of that. So, and it will distract you from solving the problem if you think about it. It'll give you less brain power to solve the problem with. So don't ever think about difficulty levels. Ever don't do it unless you write tests. All right. Let's do another one. As far as, okay, the question about percentages, I mean, are there any, Tutor, I'm afraid I don't really understand exactly what this question means. But the point of this observation above, which I should probably write down explicitly, is that if one of these quantities increases, then all of them increase. So the point is, if you are comparing these quantities, as we were in the last problem, then it's always safe to replace any of them with any other of them. Okay, on the other hand, if the actual value makes a difference, then you have to be careful, because as you can see here, the values are not the same. I mean, these are all different numbers. But the point is, if this is bigger than this, then you know absolutely with certainty that all of these other ones will also be greater than all of those other ones. So, yeah. Same thing with, it's the same as anything else that scales up with anything else. Like, you know, if you have more taxable income, then you will definitely owe more tax. So if the question is like, do you owe more tax? You could substitute, do you have more taxable income? The same question. Okay. So, I mean, the numbers shouldn't matter. If you can do it, you can do it. All right, let's try another one. How about this? Give it a shot. I mean, if you also, when it comes to questions like that, just try to experiment with it. Just play around with it. Toss some numbers in there and see what they do. That's good. It's a key component of reviewing problems. Okay, remember where you find multiple choice answers, guys. Not in the chat box. Okay, I'm going to annoy everyone and clear out your answers because I realized I didn't clear them last time. So I can't tell which answers are answers to this and which answers are still from the last problem. So if you entered an answer, please enter it again. Sorry about that. But yeah, my mistake of not erasing them before. Okay, you should pick something pretty soon. That is a thing. You have to guess. Then go ahead and guess. All right, interesting problem. Here's what people are putting. I mean, as you can see, the crowd thinks it's either A or D. So, see what's going on. So you have a formula. But again, remember during the first step, during your first read, again, you're not trying to do math. It's kind of like that problem with the total fine that we saw a little while ago. If you're just ask yourself, just get acquainted with what's actually in the problem. Like in that problem with the total fine, this is where you would realize that, oh, a total fine is the only thing that is there, and I don't need to worry about adding daily fines because they don't talk about them. So like here we have interest is I, N is the number of years. Here's a formula with I, R, and N in it. And R is the percentage interest rate. So if R is 8%, that's not 0.08, that's just 8. Okay, so in the formula, the only unknowns are I, R, well, R and N. It's a formula for I. So basically, if you have those, then you get I. Okay. Well, that's cool. Now let's take a look at the statement. So the question is the interest rate paid by the bank greater than 8%? So a yes response would mean that it's more than 8%. And a no response would mean that it is not. Okay, I've reactivated the chat box in case anybody has questions. So that's what you should do, right? First, on your paper, again, your paper is that kind of annoying yellow color, right? So on your paper, you should immediately write those two things. So those are the goals. Statement 2, same deal. Okay. That's what you should write on the paper. This is what should go on your paper. Just do it first. And again, when you're practicing these problems, do this for every yes/no data efficiency question. Just do it. Even if you find the problem easy, do it anyway, because that's how you build habits, is by doing something every time, even when you don't think it is technically necessary. Okay, so statement 1. So here's your formula. In statement 1, they do tell you it's 2 years. So this is 2. And this is 210. What does that mean? This is statement 1. Ah, this means you can solve for R. Because, I mean, if you can see what the steps are, right? Like first, you don't have to do them, but you're going to divide by 1,000, then add 1, then square root. And then you'll have 1 plus R over 100, which would clearly let you solve for R. So there's no point in doing that. And then if you look at these goals here, the point is you're only going to get one of these. I don't know which one it is, but I don't really care because that's not the point. So, and if you did waste the time doing that solution, and I don't, you wouldn't even be able to get an exact solution unless you could somehow do logarithms in your head, but you don't need to. You don't need to do it. So statement 1 is sufficient. Okay. Now, statement 2. So you can't really solve this because there's no way, unless you want to take the square root of 1.15 in your head. Well, maybe. Let me move this stuff upward. Like, let's say that you really are sort of hell-bent on trying to solve this for R. Then you probably could. How would you have to do that, though? What's the first step of solving this? You're going to have to square root this. So how are you going to approximate that? Well, if you really are fast at arithmetic, then you can get an estimate by just squaring things. You're not going to have to do this, of course. GMAC will never make you do lots of labor like this, but you can try squaring things and seeing if you get 1.15. So, like if you square, you probably know it's got to be somewhere in between 1 and that. If you square 1.07, for instance, then if you square that, that's going to be 1.1449. And if you square 1.08, then you get, I mean, I'm doing this with a calculator, but you could do it out on paper. So 6.4. So I know that this actually has to be less than, this is going to be somewhere between 1.07 and 1.08. Just by squaring numbers. So then subtracting 1 and multiplied by 100. Oh, hey, that worked. So this is sufficient because R is definitely less than 8. Cannot be greater than or equal to. Can you just put the expression into the formula? What is the expression? You could, oh, into the formula for I, but think about goals. I mean, think about why you would want to do that, because you wouldn't want to do that. I mean, this is why you write this stuff out on paper and look at it with your eyes. Because the goal is R, and you already have something about R. So there would really be no point in doing that, because this would tell you about interest. But we don't want to know about interest. We want to know if R is more than 8, and this is already a statement about R. So this is not going to help you. And that's why you write these and you look at them with your eyes. Okay. Yeah. So absolutely you have to solve for R. Yes, you do. Because this is not an equation. This is an inequality. So how else could you have done this? You didn't feel like square rooting something with brute force. How else could you have done this? Would you want to plug in 7? Because again, the deal is, yeah, the threshold value is 8. I mean, you don't have to bother plugging in anything except 8. So if you're trying 7 or 7.5, you're kind of wasting your time. And when I say kind of wasting your time, I mean you're completely wasting your time. So, I mean, all you need to do is to plug in the one threshold value that you care about, and then see what happens. So, let's see what happens. Well, that would be 1 plus 8 over 100 squared. So that's 1.08 squared, which is we can work that out to 1.1664. So, okay, wait, I think I did something wrong with the previous approach. So we'll have to revisit that here in a moment. Because this, if you plug in 8, then this is what you get. So let's think about this on a number line, because this is actually going to be not sufficient. So and we're going to have to revisit the other approach there. But okay, here's a number line. The point is, here's 1.15, and here's 1.1664. So this there is what you get by plugging in 8. This is what happens. The result if R is actually equal to 8. And I mean, common sense, if you have smaller values of R, it's going to be smaller, right? But these are the values that satisfy the statement. So R can actually be anything from this value greater than this value. So it's not going to be sufficient, because anything to the right of that. So that's going to include some values that are here, which would be these, and is also going to include some values that are here, which would be these. So it's actually not sufficient. And this is going to be overall a like alligator. So let's revisit the approach we did before and see why that didn't. Okay, so here is the statement, and then by brute force we figured out by just squaring numbers. We had figured out that R is between 7 and 8. That the value of R that does that. Okay, that's the value. The value that gives 1.15 is between 7 and 8. So actually, yeah, this is just the same sort of thing that we did from this point. Once you realize that, then it's the same realization that we made on the previous page, which is this. Because this value of R, this is going to be the threshold value of R. It's an inequality, it's not an equation. So, I mean, this is not, R between 7 and 8 is not the R's that solve this. But there's some, the point is that this is actually a single R in that range. So, some threshold value between 7 and 8. So that would be this value. That's why it's still insufficient. So Yeah. I mean, there's that we definitely don't know we can get it because we can't get it. I mean, the second thing is not sufficient. So, I mean, if you're not clear on why we have to solve the inequalities, I mean, because this is not, you don't want to get caught flat-footed thinking something like this. I mean, I think the part of the reason is the word that you're using here. I mean, it's not an equation, it's an inequality. And it's fundamentally a different thing. But just consider the following, right? Just consider a very simple problem. Like, is x greater than 10? Okay. If you see statement 1, x is greater than 12, then that's sufficient. But if you see x is greater than 8, that's not sufficient. So there you go. I mean, this should explain everything about why we actually have to do the work. Same reason we have to do the work here. And if you flip these inequality signs around, this one's not sufficient, that one's sufficient. So you can't tell how that's going to work out without doing the work. Like here you can, but in these things, yeah, right. So if you understand why these turn out differently here, then you can understand the same thing about this. So. And I mean, if you can, by writing these things down with and looking at them with your eyes, you're probably sick of hearing me say that, but that's what'll keep you on task with knowing which way this inequality has to go. So, yep. Okay, so we have quite a few problems left on the slides, so we're going to do more of this next time. That's all the time we have today. So immediately finish the problem exactly. The ending time. Neat. So we'll do more of this next time. In the next session, we'll do more of the organizing word problems because it's good stuff. All right. And that's it. Good morning, good night, good afternoon, depending on where you are in the world. And good luck. I would be a terrible politician. Please don't vote for me for president. All right, guys. Have a good day.